Solve exponential equations. These equations are all exponential, and you'll notice when we solve these that the bases are not the same, or you cannot attain bases that are the same. So what are we supposed to do? The big idea here is that if you cannot get the same base, that you will need to utilize the relationship between logs and exponentials. And what is that? Well, log and exponential are inverses. So that would mean that logs cancel exponents, or exponents cancel logs. In this case, we're dealing with exponents, and I'm going to look at problem A. We cannot write 41 as a base of 10. We cannot find a base that both of these could be written as. It doesn't necessarily have to be 10. So what we'll do is we'll start by taking the log of both sides, because these are exponential, and I'm trying to get rid of that because that exponent stuff isn't helping me very much. Now on the left side here we have log of 10 to the x, and log, as it's written here, is a common log. Let's use our power property to bring down that x, and we have log of 10 times x equals the log of 41. Now log of 10 is just a number. Hopefully you know what it is. It's 1. If you didn't know what it was, you could take the calculator, since it's base 10, enter log of 10. But essentially here we have 1x equals the log of 41, which is not a whole number. You could get a decimal approximation here. This says x is approximately 1.613. And there's your solution. You could check that number by plugging it in. 10 to the 1.613 should be approximately 41. Now problem B here is a little bit different. We have kind of a sum and a multiplier in front of our exponent. Our e to the negative x has quite a few other things going on besides just that. So let's just solve this like we normally would, trying to get x by itself. So we're going to get rid of this e eventually, the 2 and the 3. Let's start with the 3. I'm going to subtract the 3 and try to get this exponential part by itself. So we have 2 e to the negative x. Let's get rid of that 2. Now we have e to the negative x essentially equals 1.5. And again, what I'd like to do here is utilize the fact that exponents and logs are inverses, because we want to get to x. We want to get rid of this e base, this exponential portion of it. So I will take the log of both sides, and before I just write log, I'm going to think for a second, because this is base e. Natural log is the base of e. So if we take the natural log of both sides, you'll see what happens here is that natural log and e cancel each other out. Because remember, that's kind of like log base e of e to the negative x. That kind of drops out. So we'll have negative x equals the natural log of 1.5. That's not quite our answer. We'll just need to get rid of that negative. Change this sign, and there's our answer. So x is approximately, if you use your calculator, the natural log of 1.5 is approximately 0.4055, and remember that answer is negative. Final problem. Still we have an exponential equation. We've got 50 as our base, 2 as a multiplier in front. So let's try to get that exponential piece alone. So divide by the 2 right away. Kind of simplifies your problem and makes it a little easier to look at. Now remember, this is a power on x, so I have 50 to the x minus 1 power. This answer is not going to be 4 or 3. 50 to the third power is much, much bigger than 150. So we're going to need to solve this. We can't write these as the same base, so again I'm going to take the log of both sides. You could take the log base 50, but that's not going to be very useful to us ultimately here when we try to solve. So power will come down in front. That's a property of logs. And we will be solving this equation from here. Now, trying to get x by itself, I would divide first by the log of 50. And then the last thing you will do to get rid of this minus 1 is to add 1. Now, if you evaluate this in your calculator, the log of 150 divided by the log of 50, and add 1, you're going to get x, which is approximately another irrational answer. It will be 2.2808. Again, you could check that answer by plugging it in. X is approximately 2.2808.